Okay, this is an AP problem from 1994. It says there is a circle that is inscribed in a square as shown in the pink picture. The circumference of the circle is increasing at a constant rate of 6 inches per second. So they are telling you that dc dt, the rate of change in the circumference, is increasing at a rate of 6. So that's one of the pieces that's given. And it says find that rate at which the perimeter of the square is increasing. So first thing I'm going to notice in this picture, notice that the radius of the circle is the same as half of the distance of this square. So what they're asking you to do is, if we call perimeter P, they want you to find dp dt. So notice I need to come up with an equation for the perimeter. But if this radius is this piece right here, the entire length of the square is 2r. Perimeter is just adding up with the 4 sides. So the perimeter is really 8r in terms of r. But I need an equation that relates the variable that I'm trying to find, which is dp. So I need a p. But then the only thing they give you information about is dc dt, which is really the circumference. So I want to get rid of this r because I don't have any information about r. But I do know that the circumference equation is c equals 2 pi r. I can solve this for r and substitute this r for c over 2 pi. So the perimeter can be rewritten like this, c over 2 pi. So my perimeter equation is 4 over pi and then c on the top. So here's an equation that relates perimeter with circumference. So this is what I'm going to take the derivative of. And when I take the derivative of this with respect to time, I get dp dt equals 4 over pi times dc dt. Plug in the 6, I end up with dp dt equals 24 over pi units inches per second. Okay. Second part, at the instant when the area of the circle is 25 pi. So they're telling you that the area of the circle is exactly 25 pi at one moment in time. They want you to find the rate of increase in the area enclosed between the circle and the square. So what they're looking for is the rate at which the area of this shaded region that I have here is changing. So the area of this shaded region, notice, is really, I'm just going to use A for area, is really the area of the square minus the area of the circle. So area of this square is, again, if the side is 2r, area would be 2r times 2r, which is 4r squared. I know the area of a circle is pi r squared. Okay? And notice at this point, okay, I don't have any information about r, but now we can find information about r because we knew that the circumference is 2 pi r. Take the derivative of this with respect to t. So dc dt is 2 pi dr dt. And I knew that dc dt was given, so I can solve for dr dt and figure out this is 3 over pi. So this is one way to go about it. You can either do it this way, or you can go back to this and do this substitution again. So there's a couple different ways you can approach this problem. So I'm going to take this derivative with respect to t. dA dt equals 8r dr dt minus 2 pi r dr dt. There's my derivative. Plug and chug. You have dr dt. Your r is going to come from the fact that I want the area of the circle to be exactly 25 pi, which would imply that your r is 5 at that moment in time. There's my r. There's your dr dt. Plug and chug. This is no calculator, so leave answers exact. You get 120 over pi minus 30. Units are inches squared per second.